Okay, so here's problem number 2 on your guided practice. This says the integral of 7 square root of x minus 10 over x to the fourth plus 7 dx. Okay, so the first thing that we need to do before we start to use the power rule is to kind of get this into a form where we can actually use the power rule. So the first thing I'm going to do is rewrite this by changing that square root of x into x to the 1/2. So remember we did that when we took derivatives. We have to do that again when we take antiderivatives, because in calculus this square root of x notation really doesn't do us any good. Also, this x to the fourth that's in this denominator right here, before I can use the power rule, I have to move that up to the numerator and make the exponent negative in order to be able to use the power rule. So that's what I'm going to do first. I'm going to start off by putting that 7 in front of an integral sign, and then square root of x I'm going to write as x to the 1/2 dx. Okay, I'm going to do the same thing, well, a similar thing to the next term. I'm going to bring the 10 in front of the integral sign, and then instead of 1/x to the fourth, I'm going to write this as x to the negative fourth power. Okay, and then dx. And then plus, now whether or not you want to bring the 7 in front of the integral sign, it doesn't really matter too much. Most of the time I'll probably just leave that in, since it's the only thing going on in that particular part of the problem. So I'll write that as the integral of 7 dx, but I could have just as easily written it with the 7 on the outside of the integral sign. So it's really up to you as you start to solve problems what you feel most comfortable with doing. Okay, so now we're going to actually take the antiderivative using our power rule for antiderivatives. So this is going to become 7x, and then I'm going to take 1/2 and I'm going to add 1 to it. Okay, and then I'm going to divide by 1/2 plus 1, and I of course know that 1/2 plus 1 is 3/2. Okay, we'll clean that up here in just a second. Now I'm going to move on to the next term, so I have a minus 10, and then I'm going to increase the exponent of x to the negative fourth by 1. And then, of course, when I divide by that, that gives me negative 3. Okay, and then remember, if I take the antiderivative of 7 dx, well, the antiderivative of 7 would just be 7x, because if I took the derivative of 7x, I would be given 7. Okay, so that one is kind of an easy one. You just kind of have to get used to taking the antiderivative of a constant. Okay, and then of course don't forget your constant of integration. We have to have that at the end of every indefinite integral problem. Okay, so the next line is going to just be me cleaning everything up. Remember that if I divide by this 3/2, okay, so let me circle that with my laser. When I divide by 3/2, that's really just multiplying by the reciprocal, which in this case would be 2/3. And then I have x to the 1/2 plus 1, which is 3/2. Okay, and then if I take this negative 10 divided by negative 3, that actually gives me a plus 10/3 x to the negative 3. Okay, and there's nothing really else that I can do with the 7x plus c part. Okay, so let me see if I can move this to a new slide now. So let's see here. What did we... 7 times 2/3 x to the 3/2, and then we had plus 10/3 x to the negative 3, and then plus 7x plus c. So that was what our previous line was on the last slide. So now let's clean this up and get our final answer. So I'm going to multiply the 7 and the 2/3. That's going to give me 14/3 x to the 3/2. And then I'm going to write plus 10/3, and I want to make that x to the negative 3 have a positive exponent. So I'm going to write it in the denominator and make it x to the positive 3. Okay, and then I'm going to write plus 7x plus c. Okay, so what you had to remember on this problem was anytime you have the square root notation or any type of radical notation, that needs to be changed to exponential form so that you can actually use the power rule. And then anytime you have an x in the denominator, okay, raised to some power, that needs to be moved up to the numerator and make the exponent negative so that you can actually use the power rule. All right, let me know if you have any questions on that.